In this tutorial, we'll be discussing Dalton's law of partial pressure. Now remember that the actual particles themselves are extremely small, especially when you compare it to the space between the particles. So therefore, they don't really know each other exist. They don't interact with each other. So the partial pressure then adds up to, say, however much this pressure that has, plus whatever pressure this particle has. So notice the 2 and the 4, put them together, they're going to add up to 6. They don't interact with each other, they just take up the same vessel. So Dalton's law of partial pressure indicates that pressure depends on the total number of gas particles, not the type of particles, because the particles themselves are so small in comparison to the space between them. The total pressure exerted by gases in a mixture is the sum of the partial pressures of those gases. So here, 1 atmosphere of pure nitrogen, 1 mole of pure nitrogen is going to equal 1 atmosphere. However, if we have 1 mole of something else, like a combination of oxygen and helium, as long as it's still going to add up to 1 mole, it's still going to be 1 atmosphere. Here we have 3 things. As long as it adds up to be 1 mole, it's still going to be 1 atmosphere. And that coincides with the molar volume. The air that we breathe on a normal basis is a mixture of gases. Nothing is really pure in nature. So it's actually mainly nitrogen and oxygen. However, we do have some carbon dioxide in there and some water vapor in there, amongst other things. Alright, so let's take a look at a few practice problems. A scuba tank contains oxygen with a pressure of 0.45 atmosphere and helium at 855 millimeters of mercury. The first thing that you should notice is the fact that one's in atmospheres and one's in millimeters of mercury. Those have to be the same units. What is the total pressure in millimeters of mercury? So that tells us what we actually need to do. So we need to convert the atmospheres to millimeters of mercury. So let's do that first. 0.450 atmospheres over 1. There's 760 millimeters of mercury in each atmosphere. So in 1 atmosphere, there's 760 millimeters of mercury. So 0.45 times 760 comes out to be 342. What is the total pressure? We're going to add that 342 to the 855. And that's going to equal 1,197 millimeters of mercury. Let's do one more practice. For a deep diver, a scuba diver uses a mixture of helium and oxygen with a pressure of 8 atmospheres. If the oxygen has a partial pressure of 1,280 millimeters of mercury, what's the partial pressure of just the helium? Alright, so if you notice that the answers are actually in millimeters of mercury, that's telling us we need to convert those atmospheres to millimeters of mercury. So in every atmosphere, there's 760 millimeters of mercury. So 8 times 760, 6,080 millimeters of mercury. That's going to be the total. If oxygen makes up 1,280 millimeters of this, that leaves 4,800 millimeters of mercury for the helium. All I did was subtract, and that gives us C. And that is how you calculate partial pressures.